Well, welcome everybody. Thanks so much for joining me today. My name is Brandon Minnick, and in today's session, we'll be talking about choosing the best mobile app framework. Now, before we get started, I want to draw your attention to the bottom of the slides where you'll see these two links on just about every slide today. On the bottom left, this is my Twitter handle. If you have any questions, feel free to follow up with me. This is the best way to get in contact with me. My direct messages are always open. So if you have any questions, feel free to shoot me a message and we'll chat. And on the bottom right, this is a web page that I put together just for this session today. And it contains everything we're going to talk about. So this is where you'll be able to find the slides, the recording, and if you're interested in learning more about the different mobile app frameworks, I've also included links to help you continue going down this rabbit hole. Now, I decided to put this talk together because it is hard to determine a mobile framework, but I also want to highlight the fact that, yes, I do work at Microsoft. Yes, I used to work at Xamarin. Yes, I make iOS and Android apps myself using Xamarin. I have a couple in the App Store. But this talk is not to get you to use Xamarin or to use Microsoft products at all. I promise this is just a completely unbiased comparison against all of the available options. And to basically just help you choose which one is the best for you. And when looking around, choosing a mobile development framework is really hard. You know, put yourself in the position where your manager comes to you and says, "We need to make a mobile app, and you need to decide how we're going to do it." And so what do you do next? Well, you start Googling around, like how do you even make a mobile app? What programming languages can you use or should you use? There's cross-platform frameworks. There's web apps that we can run as mobile apps. And when searching around myself, even though I've been making mobile apps for 5 or 6 years now, I still find that learning all of the information about the different frameworks is really difficult. And part of that is because there's people promoting their own mobile frameworks that want to highlight the best things about theirs and maybe ignore some of the downsides. And I've seen charts that show the big comparison charts, and they'll say this framework's better than that framework because of X, Y, and Z. But they'll also leave out other things that framework is better than this framework. So it is really hard. And since mobile debuted back in the mid 2000s, is that what we call it? The mid aughts, the mid zeros. There's been a lot of mobile app frameworks that have also come out. There's also been a lot of mobile app frameworks that have gone away in that time period. And so there's just a lot of information out there, and I wanted to condense it and put it together for us today. But the big thing to keep in mind is that there's a lot of considerations when choosing a mobile framework. So it's not just about what's the best. There's considerations like time to market. So when your manager comes to you and says, "We need to build a mobile app, and by the way, it needs to be done in a couple months," well, that short time to market is going to drastically impact what you choose, because certain platforms will require more developers. Certain platforms like cross-platform frameworks or progressive web apps, you'll be able to build and deploy and get them in the App Store much quicker because you have essentially less code to write. You can write the code once and it runs on both platforms. So time to market, app performance. This is becoming less of a problem, less of a consideration nowadays, but it is still something to keep in mind. I I keep it on this list, even though most phones nowadays are powerful enough to where performance really isn't a problem no matter which framework you go with. And also, the frameworks have matured a lot in the last 10, 15 years, and they've been able to uh, improve their performance as well. But if you're using or if you're creating an app that needs to be very performant, maybe it's some sort of 3D game that's rendering a lot of graphics, then yeah, performance is definitely something to keep in mind. That being said, most apps nowadays are just data entry apps where we're entering in text or we're scrolling through lists. And so for, I'd say 95, 98% of mobile apps, performance is going to be fine across the board. But if you're rendering those 3D graphics or doing something crazy like AR, VR, definitely keep performance in mind. Feature availability. This one is a big one that I see a lot, and a lot of developers end up shooting themselves in the foot because they choose a framework that doesn't have a feature that they need. So speaking of doing things in AR or VR, so augmented reality, virtual reality, well, if you make a progressive web app, it can't do any of that, or it can't do any of that natively using the native APIs for iOS and Android. And so if maybe you want to include something like geofencing or augmented reality or something like that in the future, it's important to take that into consideration when choosing the framework to make sure that you'll be able to access those platform specific APIs and be able to implement that feature. Because if not, you're going to have to go back to the drawing board once you're ready to implement it and basically rewrite the app all over again, which nobody wants to do. There are also third-party risks. The fact that iOS is created by Apple and they have their own development kit with Xcode, and Google makes Android and they have their own development kit inside of Android Studio. Those are the first-party platforms, but other companies like Microsoft with Xamarin, Facebook with React Native, Google also makes Flutter, and there's all these other third-party companies that create these toolings as well. And not that I think that any of the ones we talk about today would pull the plug tomorrow, but it is their prerogative, and they could stop working on and providing updates to their platform whenever they want. There's nothing legally binding them to continue to release updates supporting the latest versions of iOS and Android. So while I consider this a low risk, do know that it is a risk going with a third-party framework. Hiring. This is probably one of the biggest ones that we don't talk about enough in the mobile world, because what good is choosing a framework if you can't find developers to build it? So the different frameworks we're looking at today, they all are built using different languages. So you can use Swift, you can use Java, you can use Kotlin, you can use Objective-C, C#, JavaScript, Dart. All these different languages are available. But if you don't have, for example, C# developers nearby to hire and to join your team, then you're going to struggle to build that app in something like Blazor or something like Xamarin, which requires a lot of knowledge of C#. So another really big thing to keep in mind is, what does our candidate pool look like? Or rather, if you already have an engineering team, this is common for a lot of companies that say you have an existing website, so you have engineers in your company already that maybe we could repurpose into mobile engineers. Well, what technologies are they familiar with? Are they already using something like React? Well, maybe we could use that for a progressive web app, or maybe that's a great gateway into React Native. And so always check out what your hiring market looks like, what your existing teams look like when selecting your mobile framework, because this will have a huge impact. And then finally, we get down to the costs. So development costs are obviously going to impact everybody's app development, but certain platforms will have a lower development cost than others. Now, there are trade-offs here, and we'll dig into these for each platform, but that sometimes can coincide with maintenance costs. So maybe your development costs are cheaper, you can get the app to market quicker, but it's going to cost you more to maintain the app in the long run. So if this is an app that you're building that is going to be a cornerstone of your company, that's going to exist for 5-10 years, well, maintenance costs will quickly outspend your development costs no matter which platform you choose. And so maintenance is a very, very important thing to keep in mind when thinking about which framework we're going to use to build our apps. Okay, so enough talking about the apps. Let's dig into the different frameworks available to us. And the first one we'll be talking about are first-party native apps. So by first party, I mean you are using the tools that Apple and Google build for developers to make apps for their operating system. So Apple owns and creates iOS, Google we'll say owns and creates Android, although Android did originally start as an open source project. Google has essentially adopted it and has become the de facto owner and maintainer of it. And both Apple and Google provide their own IDEs where we can build native apps. And if you follow me down the list on the right, so we'll see that, yes, the owners are Apple and Google. And each of these I've given a green, red, yellow, or even a gray check mark. If gray is kind of neutral, then the fact that it probably doesn't matter too much. It's not really good or bad. But when we start talking about the UI and the UX, you're not going to get a better experience than going native. And so what I mean by this is both iOS and Android have APIs for their UI. So when you want to put a button on the screen on iOS, that API is called a UI button. On Android, that API is called an Android widget button. And when you use that specific API, they will draw a button on the screen, and it is the native button, and it's made to look and match the look and feel of iOS and Android. So on iOS, they have a very flat, very minimal design that they promote in their human interface design guidelines. And so when I say put a button in the center of the screen, I get this very simple button. It's actually just blue text. So it almost looks like a hyperlink. Whereas when I do the same on Android and say put an Android widget button on the center of the screen, well, I get this nice material design with buttons with square corners and shadows. Android likes to use material design, which shows off a lot of elevation. So we get a lot of shadows and kind of ripple animations, which are really cool. And these are all available and included in iOS and Android. And because you're using the first-party frameworks, you have access to all of those APIs. Now, your development speed here is going to be slow. And what I mean when I say slow, I mean slower than the other options that we'll talk about in this presentation. The development speed is slower than the other options because you essentially have to create the same app twice. Well, you do. You have to create the same app twice, because if you create it on Apple's tools in Xcode, you'll create that app using either Swift or Objective-C. And then when you want to publish that same app to the Google Play Store, well, you have to create it in Android Studio using Java or Kotlin. And so because we can't reuse the same code, and also because iOS and Android promote different architectures for architecting your apps, you end up with an app that has a similar look and feel on both iOS and Android, but the code that powers it is completely different. So different sets of bugs. And speaking of maintenance costs, which we'll I also have flagged as high, which again means higher than the other alternatives, is when you find bugs, you have to fix them on both platforms. When you want to add a new feature, well, you have to add it in both platforms. So you can't just add that feature once and expect it to work on both Apple or both iOS and Android, because they're two completely different code bases. So what you're looking at is either having two dedicated teams, one to write your Swift code for iOS, one to write your Java or Kotlin code for Android, or you have one team that pivots between the two. So one common approach is to create the iOS app first. Well, create one of the apps first. So let's say you create the iOS app first, and then once it's done, you essentially port that code into Java or Kotlin for Android. So I've seen teams do this where they put their senior engineers on the iOS team, build that out, get the iOS app in the App Store first, because maybe they know their target market is mostly iOS developers. And then they'll kind of throw the code over the fence to a junior engineer or an intern to say, well, just port this code from Swift into Kotlin. And that's one approach to doing it, but you still will have to build your app twice. You're still going to have to fix bugs in both code bases separately. You're still going to have to add new features to each code base separately as well. But the benefit here is your performance is going to be very high. So compared to all of the other frameworks that we'll be discussing later, you cannot get better performance than building your app using the first-party native tools. And this, along with the risk of using a third-party framework, is what still drives a lot of developers to use the native development tools today. And so, for example, what I mean by performance, things like a button click. So I put a button on the screen, and when the user taps it, well, iOS and Android have to notify me. They have to raise an event, which notifies the developer that a button's been tapped. And then the developer can handle that action, write the code to do whatever the button's supposed to do. Well, with first-party native tools like Xcode and Android Studio, if you use these to build your app, you are going to get a native response time, which is about 10 milliseconds. So almost instantaneously, you will know when that button is tapped. And honestly, there's no better tool that'll give you better performance unless you are willing to drop down into a lower level language like C, and then you'll be able to do all sorts of crazy things like manage the memory yourself and really fine tune and optimize it. But for all intents and purposes, first-party native frameworks are going to give you the best performance. The programming languages, we touched on this. I have Swift and Java listed on this chart because they are the most popular. But Kotlin is quickly becoming the favorite language for new Android apps. And I've even seen apps that were originally created for Android in Java that developers are now adding in new code in Kotlin, which is pretty cool as well. The maturity of these, obviously, they're very mature. When iOS first debuted, they didn't open up these tools for third-party developers. I think it took until, I want to say iOS 3, until we, as developers, could make our own apps for the iPhone and add them to the App Store. But for all intents and purposes, these tools have been around for as long as the operating systems have existed. So they've worked out a lot of the kinks. You're not going to experience any bugs because of the tooling. And while bugs will still exist, there's new APIs coming out every year. Like iOS 14 is right around the corner. Android just released the beta of their new operating system. And obviously there's going to be new bugs found that they'll iterate on and they'll fix them over time. But in general, the more mature the framework is, the more robust it is, and we'll say the more pleasant the development experience is because they've had enough time to work out the kinks. The feature access, totally complete. You have access to all of the APIs on iOS, all of the APIs on Android, of which I think both platforms have over 100,000 APIs that you can use for things like Bluetooth, geolocation, getting the battery status, using the camera for augmented reality. There's all sorts of libraries available that are baked into the OS that are highly tuned by the iOS and Android devs that we can take advantage of. And because we're creating our app using the first party tools, we have access to all of them. There's literally no limitations. And when it comes to open source, I have a no/yes here because Apple's iOS operating system and their tools are not open source. Typical Apple, they like to keep their secrets and hold them very close to their vest. But on Android actually started as an open source project, which, as I mentioned earlier, Google essentially adopted and has now become the biggest contributor maintainer. But at the same time, Google doesn't open source everything. So you still will run into things that are not open source. And we'll say maybe this is a problem, maybe it's not. For the first party platforms, as much as I wish they were open source, so I could dive into the APIs and see how they work behind the scenes, it doesn't really impact any risk, because if Apple decides to stop creating development tools for iOS, it's probably because they stopped working on iOS. So iOS probably doesn't exist if Xcode goes away. And so I'm not really personally too concerned about them being open source so that we can fork it and maintain it as developers to continue supporting our apps, because I can't imagine a world where Xcode doesn't exist, but Apple keeps releasing new versions of iOS. Okay, so moving on into the third-party tools, the next subject we'll talk about is progressive web apps. So first, we should probably answer the question, what is a progressive web app? Well, it says web app in the name, and so that kind of implies that it's a website, and that's exactly what it is. It's a website, but the difference between a web app and a progressive web app is progressive web apps, or PWAs. If you'll hear me say that abbreviation a lot. PWAs are different from normal web apps because when you visit a website in your browser, so let's imagine we're on our laptop, we've got Chrome opened up, and we navigate to a website in the browser. If it's just a normal web app, that website is built and running on the server side. So we're just seeing essentially just the UI, but all that business logic, the guts, and of the if you're doing anything with databases or anything like that, that's all running server side. Progressive web apps flip that. So when you visit a website that's a progressive web app, the website actually downloads to your client, so to your browser, and everything runs client side. And so you get that ability to have everything run more smoothly. I've also seen some amazing 3D games built using progressive web apps, because then they can take advantage of the horsepower on your computer. There's no latency from communicating with the server. And so PWAs all run on the client side. Now, how does this come into mobile? Well, I've chosen to focus on PWAs and not web apps, because web apps were always an option for creating a mobile app. You could always essentially build a website and jam it into a mobile app and deploy that to the App Store. And yeah, that worked, but it doesn't look great. The users can tell when it's not native. Like when you load an app and it doesn't have a good response time, or it doesn't have buttons where you would expect the buttons to be, it just feels weird. That's usually because it's a web app. But with progressive web apps, we're not relying on the server anymore, and we're running everything on the client side. So we get a huge improvement bump there. And so if you are interested in using web technologies for a mobile app, don't even look at normal, we'll say normal web apps, jump straight to progressive web apps. But let's break these down. So following that chart in the top right, there are different, we'll say multiple framework owners. So Microsoft has a solution with Blazor, there's React, there's NativeScript, Angular, Ionic. There's a bunch more that are either new and still coming out, or I don't even know about and or wasn't able to fit on this list here. So there's a lot of different options you have. So if you're, say, a C# developer, you'll be more comfortable in Blazor. If you're a JavaScript developer, you'll be more comfortable with React. But one of the downsides of PWAs is your UI and your UX is all bespoke. What do I mean by that? Well, with the native frameworks, those frameworks use the built-in UI and UX APIs for drawing those buttons on the screen, for navigation. And so when you build a progressive web app, you're not using any of the iOS or Android APIs. You're building it just like you would a regular website. Now, there's a lot of tools available that help you theme it so you can essentially make it look like a native iOS app. But in reality, what you've done is written that either HTML, CSS, JavaScript, whatever code you're using to build the PWA, you've written that code so that it looks like the native iOS and Android buttons. But in reality, you've done that all yourself. That being said, your development speed is going to be pretty fast. Even though you are building your UI and your UX yourself, there's libraries to help you out so that you don't have to reinvent the wheel. And at the end of the day, you are building a solution that is what we call write once, run anywhere, meaning you write your web app once and it'll run on both iOS and Android. So you don't need a second team of developers to focus on the Android app, because as soon as you're done with the web app, it just works on both platforms. Now, your maintenance costs, I put this at medium because for the most part, it'll be low, because when you add a new feature, you only have to add it once, because write once, run anywhere. When you fix a bug, you only have to fix it once, and you fixed it for both iOS and Android. But the fact that we created a bespoke UI could cause some inflated maintenance costs in the future. And the scenario that I always point to is, remember when iOS completely changed how their UI looked from iOS 6 to iOS 7? They went from this, what they called a skeuomorphic design in iOS 6 and earlier, where everything matched real world things. So like there was like green felt and leather with stitching in it, and everything had kind of this real world equivalent to it. And then they switched to iOS 7, where they got rid of everything. They got rid of all of that, and everything went flat. So everything became this very clean, flat UI that they're still using today. Well, if you had a web app during that time, immediately your web app is going to look out of date on iOS 7. And because you have a bespoke UI, you now have to recreate that entire UI. Whereas if you had been using the native tools, or even the cross-platform native tools that we'll touch on in a minute, all you would have to do is rebuild the app, and you would get a lot of that for free. So like I mentioned earlier, iOS has an API called UI button. And when I use UI button and compile my code, it already themes it to look like what the operating system recommends, the human interface guidelines. Whereas with our PWA, if the iOS or Android operating system theme dramatically changes again, which I'm sure it will happen, I think it's inevitable, then we're going to have some extra maintenance costs there to redo the UI. But in general, day to day, fix a bug once, fix it on both platforms. Add a feature once, it's added on both platforms. Now, performance, I flagged this as medium, but like we mentioned earlier, performance for probably 95% of apps is going to be perfectly okay. And that's true with web apps as well. But we should highlight the fact that they aren't going to be as performant as if we had built it using the native APIs. So one big example is that button click that we talked about earlier. So when the user taps a button, the native APIs will handle the event and alert the developer, or run the code rather, that executes when the button's tapped in 10 milliseconds. So we get about a 10 millisecond response time when we use the native UIs. Original web apps, so not progressive web apps, but the older web apps, that delay went from 10 seconds or 10 milliseconds, rather, 10 milliseconds for the native app. The original web apps had about a 300 millisecond delay. But with PWAs, that delays come down to around 100 milliseconds. So yes, response time of 100 milliseconds is dramatically longer than 10 milliseconds. But if you step back and think about what that actually means, well, 100 milliseconds is actually imperceptible to a user. So if you gave somebody an app and said, here's a native app, how fast does it respond? And here's a PWA, how fast does it respond when you push the button? They'll give you the same answer, because 10 milliseconds versus 100 milliseconds really is imperceptible to the user. Now, maybe there's some people out there that can detect it, like the people, and they're probably the same people that are just tech nuts that have the super high resolution monitors or play games that run at 60 or 120 hertz refresh rates. They might notice a difference, but your average user won't be able to tell. And so I marked it as medium just to make everybody aware of that. But do I think that's really a problem for most apps? No, not at all. Your programming language is going to differ between the different frameworks. So like I said, there's C# and Blazor, there's JavaScript, and I'm sure there's more, and you'll be able to find one that has a familiar programming language for you if you are an existing web developer. But the maturity of PWAs are still pretty adolescent. These are still pretty new. Not even every website is a PWA yet. And then actually not even Blazor has Microsoft's Blazor implementation. Not even that has left the preview/experimental phase. So do be aware that this is still kind of a new technology, and there could be some unforeseen hiccups that you come across as you use these tools that are still maturing. Now, probably the biggest downside is your feature access in PWAs. So you are very limited in what you can do with a PWA. And I've put together just we'll say a short list here. There are other features you can use and a lot of other features you cannot use. But the way to think about this is, because PWAs were made for browsers on a laptop, on a desktop, on a computer, think about what features would a website running in Chrome need or could have access to. So when you think about things like, well, computers and laptops, yeah, they use Bluetooth, there's local notifications, there's touch gestures if you're working on a tablet, like a Surface tablet. Pretty much every laptop has a camera, offline storage, and file access. So these are all common features that a typical web browser would need, use, or want access to. And because of that, you have access to these features on mobile as well. That being said, there's a lot of features on mobile that you will not have access to. Things that just don't really exist for laptops or desktops, like having access to vibration. Like well, maybe you do when you get frustrated, but you're not really likely to shake your laptop to use a feature in a web browser. So PWAs do not have access to the vibration APIs or geofencing or augmented reality. And this list goes on. And let's see, Danny, I saw your question pop up just for a second. And if I read it quickly enough and read it correctly enough, You're asking, are the features with the green check marks available on PWAs? Yes. The features with the green check marks are the ones we can use on PWAs. The ones with the red X's are not available, at least not today. And like I said, this is still a framework that's maturing. And there is a, I guess you would call it a governing body that's creating the specs, the evolution of web apps, the same way HTML has evolved from where it started to HTML5. PWAs have a similar governing body to help push them along. So as we evolve, things will get better, but be aware that you will be limited. So if you need to use augmented reality in your app, you don't want to use a progressive web app for it. And then when it comes to open source, some of these frameworks are open source, some of them aren't. And again, now that we're getting into third-party tools, this is where I feel more comfortable using a framework that is open source, because any of these companies could choose to stop working on their specific frameworks tomorrow. Again, not that I think they would, but it's a possibility. But if the framework is open source, there's still at least the option for me as a developer to fork it and continue to maintain it to ensure my apps will still continue to run for my users. Now, one huge advantage, and I am so jealous of PWAs, is that they can install an app on your device without having to go through an app store. So there's a GIF here on the right, and I know the animations will be a little choppy because we're not in person, and the screen sharing doesn't show the perfect frame rate. But as it goes, you'll start catching different frames of the GIF. But what you can see is I navigate to Google Maps in Safari in my browser, and when I get there, I open up the share sheet and I say, add this to my home screen. And the fact that Google Maps is a PWA, it appears now on my home screen as an app. It looks exactly the same as if I had downloaded this app from the App Store. And you'll notice when I go to force quit the app, it is running as its own self-contained app. It's not running in Safari. That is Google Maps as an app on my iPhone that I did not install from the App Store. And so this is a huge, huge benefit for PWAs versus all of the native apps, including the cross-platform native frameworks, because we have to use or go through Google and Apple's App Store process to deploy our app. So when I push out an app update, I have to first upload that app to iOS, or upload it to Apple, upload it to Google, and then they get to review it. Apple and Google have a it's like a dictionary. It's so big now, but they have a ton of rules that say what is and is not allowed in the App Store. All of the common restrictions you can think of, and then even some crazy ones like Apple has banned fart button apps, because when the App Store first opened up, there was hundreds of apps, and all they were a button that you tap on, it would make a fart noise. Those are now banned. So you have to be aware of that when you will be aware of all of these rules when you submit to the Google and Apple app stores, because they review it. And if you aren't following one of their guidelines, they won't publish it on the App Store. So yes, that's a pain as a developer. I'll be honest, as a user, I appreciate that, because it means every app that I download from the app stores has been vetted. So I know it's a quality app and it won't have any anything that breaks their code of conduct or their rules in it. But as a developer, it's very frustrating, because along with this, not every user updates their apps. And this becomes really frustrating, because I fix bugs, I add new features to my apps all the time, and I want you to have the latest, greatest version of my app so that you have the best experience. But when it comes to maintaining my app, if you are still on version 2.2 of my app which I released years ago, and now the app is on version 5.3. Well, now I also have to maintain all of the backend solutions because I still have 100 users on version 2, which is using the old APIs. And this is a tough decision to make as to when do we stop supporting those older versions of the apps, because it's kind of easy to say, yeah, the user should just go to the App Store and update it, but maybe they can't, because as iOS and Android evolve, newer operating systems don't support older devices. So they might have an older device that's locked into iOS 12 and they can no longer update the app because it only supports iOS 13, for example. And so when do we make the decision to stop supporting those old APIs and break their apps? I don't know. I honestly still haven't figured this one out, but it is going to be a decision you'll have to make eventually, unless you use progressive web apps, because then the user can install it directly from the website. And anytime they launch the app, well, the app can phone home and get the latest update. So they don't have to, or you as a developer don't have to worry about, are they on the latest, greatest version? Because you know they always will be. So huge benefit of PWAs, despite the fact that they are limited in their features, is that they can be installed just by essentially downloading them from a website onto the mobile device, which is really cool. And as somebody who doesn't do PWAs, I am very jealous of this. Okay, the next category is what we call cross-platform native apps. Now, these are a lot of words. So let's break down what that means. Well, cross-platform means that these frameworks will work for both iOS and Android, and some of them also include other platforms like Windows. And native means when you build it, it still boils down into the native binary. You still have access to the native APIs. So with all of these frameworks, they still give you the performance that you would expect and the look and feel that you would expect from a native app, but they allow you to create it in a cross-platform manner using a language or a programming language that you're already familiar with. So we're going to focus on what I call the big three: Xamarin, React Native, and Flutter. But I also want to highlight the two at the bottom, Uno and Kotlin Native. These are both what I will call rising stars in the mobile app framework world. Uno lets you build a cross-platform native app using the UWP XAML. So if you are a UWP developer and you already know how to build apps for UWP, well, go check out Uno. It's a great solution. You can still build iOS and Android apps and still use the language you know and love with UWP and XAML. Kotlin Native, same idea, but you can build cross-platform apps with Kotlin. So maybe you are an Android developer, you've only used Kotlin, but you also want to build iOS apps. Check out Kotlin Native. Okay, so the first of the big three, Xamarin. Like I said, this one's definitely my favorite. I've been using Xamarin for 5 or 6 years now, but the owner is now Microsoft. We used to be a startup. Microsoft acquired us in 2016, and since then has been continuing to invest resources and grow and develop the platform. Now, we're talking cross-platform native apps, and so yes, your UI and UX in your Xamarin app is going to be native. The way Xamarin works is it takes every single iOS API that exists, all 100,000 plus APIs, and wraps them so that we can have access to them in C#. So when you're writing your code in C#, you're still using all of the native APIs. And when you click compile, it still boils down into a native app because it is. You're literally using the native APIs. You just happen to be writing the code in C#. And the same is true on Android. We take all of the Android APIs that are available to you in Java, wrap them, and bring them to you in C#. So if you've done any native development work in Swift or Java for iOS and Android, you're going to feel right at home in Xamarin because it's literally the same thing, just using C#. But now that we're using one language, one programming language for both iOS and Android, our development speed is going to be a lot faster because now we can share code between our iOS and our Android apps. And then on top of that, there's even cross-platform UI frameworks like Xamarin Forms, which allow us to even share our UI between iOS and Android. And so you can get to a point where all of the code you write is still completely native and also shared between iOS and Android. This is, for example, the app I just released to the App Store is called Git Trends. It helps you monitor your GitHub repos to see how many views and how many clones they're getting and also where that traffic's coming from. I created that all in Xamarin using Xamarin Forms, and I share probably 95 or maybe even more than that, 95% of the code is shared between iOS and Android. So again, that helps with my development speed because I can get the app to market faster, but also with maintenance costs. When I find a bug, I only have to fix it once, and I fix that bug for both iOS and Android. And when I want to add a new feature, excuse me, I only have to add that new feature once, and it's now available for my users on both iOS and Android. Now, the performance is still high. If you note on the first party frameworks, I said performance very high because, like I said, you're not going to be able to beat that. But with these cross-platform native tools, because they still use the native APIs, because they still compile down to the native binary, they still have the native performance. Now, is there going to be a couple millisecond difference between building it in Swift versus building it in Xamarin? Maybe, possibly. But you still, for all intents and purposes, still have the high performance that you would expect as if you had built the app using the first-party native tools. Xamarin's programming language, it's all .NET based, and so I personally use C#, but because it's .NET, you can also use F# as well. And it's really cool to see apps built in F# because if you've never seen it before, F# is a what's the word I'm looking for? So C#'s object-oriented, F# is a functional programming language, and it's a totally different mindset, a different architecture. But at the end of the day, it's still built using Xamarin. It's still built using .NET, and it's really cool to see the difference for somebody like me, whose mind works in the object-oriented C# way, to then kind of have this total paradigm shift and see the same app built in F# in a functional way. Now, the maturity of Xamarin, very mature. Xamarin's been around over a decade, and so we've had enough time to continue iterating and working on the tools. And now that we're part of Microsoft, we continue to add in new features as well. The feature access is complete. Like I mentioned a minute ago, you have access to every single native API. We don't do anything fancy at Xamarin. We just wrap every single API so that you can use it in C#. So if there's an API that you want to use, like augmented reality or geofencing or anything, you have access to it as a Xamarin developer. And it's all open source. So again, this is a third-party tool. Something to keep in mind is that if any of these companies decide to walk away, which I don't think will happen, and as a Microsoft employee, I can tell you that's definitely not our plan anytime soon. In fact, we're evolving it. You might have heard about .NET 6 and Maui. That'll be the evolution of Xamarin. So Xamarin's just getting more embedded into .NET every day, which is amazing. But it is open source, so you can always fork the Xamarin repos, add new features, fix bugs. You can even respond to and look at the roadmaps and give some advice on how you might implement things as well. So feel free to join the conversation. Now, another cross-platform native tool that's very popular is React Native. React Native is created by Facebook. And again, it's a native app. So your UI and your UX will still be native, similar to what we talked about with Xamarin. Your development speed is going to be a lot faster than if you had built it using the first-party tools, because again, you're writing all your code in one language that runs on both platforms. So you can essentially build the app once with one development team, and it'll work on iOS and Android. Likewise, your maintenance cost is going to be low because, again, you fix that bug once, you only have to add the new features once, and you've fixed it and added the new features for both platforms. Same story with the performance. You'll never get better performance than the first-party native tool sets, but like Xamarin and React Native, your performance is still going to be very high. And if there is a difference, it is very imperceptible and not much of a concern at all. The programming language they use is JavaScript. So if you have existing engineers that are familiar with JavaScript, they'll feel right at home, or feel at least more comfortable coming to React Native. It's a very mature platform. I forget exactly when Facebook created React Native, maybe back in 2012, but yeah, it's almost been around for a decade. So very mature. And also, like Xamarin, you have access to all the features, and Facebook releases these through NPM. So you can always stay up to date with the latest packages. And yes, React Native is also open source. All right, the last cross-platform native solution we'll chat about is Flutter. Flutter is pretty new, but it has taken the cross-platform native world by storm. Developers love using Flutter. Flutter is created by Google. And the big difference with Flutter compared to Xamarin and React Native is your UI is actually totally bespoke. So in the same way with progressive web apps that we had to create our own UI, the way we're doing the same on Flutter. The way Flutter works is instead of using those native iOS UIs or UI APIs like the UI button, they actually just draw your UI on the screen. They use a technology called Skia. And if you can picture a blank canvas, just like an artist would have and the same way the artist paints onto the canvas, that's how Flutter works. So it essentially mimics the look and feel of a native app, but the UI is totally drawn on. And they've gone down this route because they've actually found that you can get better performance by just drawing the UI onto a blank canvas instead of using the native iOS and Android controls. Now, that better performance does have an asterisk on it, a caveat, and that it is better performance for some apps, but not better performance for others. Just kind of depends on what you're working on, how busy and complex your UI is. But do be aware that Flutter is a bespoke UI. And they do also have libraries that will help you mimic the iOS and Android look and feel. So they have, like, for example, material design guidelines so that you can drop those in, and then that button will look like a native Android button, even though it's drawn on the screen using Skia. So your development speed is going to be nice and fast because, again, cross-platform, you're writing all the code in one code base, and then it just works on both iOS and Android. And the maintenance costs should be low, but I've put this at medium for the same reason I gave progressive web apps a rating of medium as well, because it's a bespoke UI. So when iOS and Android completely redesign their operating systems and how they look, you will have to recreate your UI as well. Or if you're using one of the libraries that Flutter provides to mimic the iOS or Android look and feel, you'll have to wait for them to first update their libraries, and then you can implement it in your app. So again, just something to keep in mind. Performance is going to be nice and high, just like the other cross-platform native solutions. And the programming language here is Dart. So this is something to be aware of. Dart is a brand new programming language that was literally created by Google for Flutter. And I haven't myself yet dove into it, but I've seen it, and talking with fellow mobile developers who have used Flutter, they say it's very similar to C#. So if you are familiar with Java or C# or an object-oriented language like that, Dart should feel familiar to you. But like we talked about hiring earlier, this is something to keep in mind that when you're looking for developers for your Flutter app, will you be able to find Dart developers in your local area? Or are you comfortable taking the risk of hiring, say, a C# developer and hoping that they'll be able to learn Dart? So it's just something to keep in mind. I have heard Dart is a great programming language, and so I can't see any developers learning it, having or taking any issue with it. But it might be a little harder to find developers who are willing to learn a new programming language, or finding existing Dart developers since it is such a new language. The maturity of Flutter is very young. It's been around for a while, but it was in beta for a long time. So you might have heard about Flutter a couple years ago when they first released it into beta, but they just took off the beta tag recently. So it's only been out of beta for about a year. So not that that's bad, but be aware of that. There are still kinks to work out, just like with any framework or any tool. Like when we first released Xamarin, there was a ton of kinks we had to work out. And when when Apple first released Xcode, they had to work out the bugs as well. So you might run into a couple of things. Just be aware of it. Make sure to be helpful. Let the Flutter team know when you run into any problems, and they'll jump on it and they'll fix it. But do be aware that it is still a very young cross-platform native framework. And like with all the other ones, the feature access is complete. And also, like React Native, they release all of the updates via NPM, so you can have access to all those features that you want to use. And it is also open source. Okay, so we only have a couple minutes left, but I wanted to run through a couple scenarios because I know I threw a lot of new information at everybody today. So let's kind of look at a scenario like this where we want to build a simple app and we have a couple requirements or a couple existing, or we have existing knowledge. So for example, we have an existing website that it was created in AngularJS. Our engineering team is currently full of web developers, and this is a simple app that doesn't require many features. So what could we use for this? Well, a PWA might be perfect, and specifically using Angular to build our PWA. We already have experience in it, and it might even be possible to leverage a lot of the existing code for our existing website into the mobile app. Next scenario, we want to build an augmented reality app. We have tons of money. We have venture capital funding, and we are also weary of third-party frameworks and quite risk adverse. So because we have enough money to hire developers for both iOS and Android, let's do it. Let's build it using the native first-party native tools, because we don't have to worry about paying the teams. We've got the venture capital funding, and we don't also want to worry about the risks of using a third-party framework. And in this scenario, we have a team of .NET developers. So similar to the first one, we have an existing website, but this one was created in ASP.NET. And you might say, well, they should use Blazor. But one of our requirements is we have to build it as a native app. So since we have developers who know C# and are familiar with .NET, Xamarin's a great choice because you can still build a native app, but it's Xamarin, it's completely in C#. Okay, so in conclusion, choose the best mobile framework for your team. There really is no best mobile framework. Like I said at the beginning, I use Xamarin. I love Xamarin. I'll tell you, it's my favorite, but that doesn't mean it's the right one for you and your team to use. So when looking around and building your first mobile app, trying to decide which one to choose, make sure to zoom out, take all these considerations into account to choose the best framework for your team. Okay, so if you haven't had a chance yet, here are all of the resources from today. This is the webpage I put together for us, and on it you can find a link to download the slides. You can find a link to a recording of this session. And if you want to learn more about anything we've talked about today, whether it's Xcode, Android Studio, Swift, Java, Xamarin, React Native, PWAs, I've included links to all of those on this website as well that were helpful when I was first learning about all the differences, and I know they'll be helpful for you too. Thank you.